Um, what I want to talk about today is one aspect of automated testing. When I spoke to you on Monday and gave you an overview of this module, one of the things I mentioned was that testing is a really important part of the agile approach towards software development. We do testing continuously throughout the development life cycle. And so because we do it continuously, we can't really be expected to do manual testing. It has to be automated. And the benefit of automated testing is that you can rerun your tests many times, which is something that you would want to do. In fact, if you've been keeping an eye on the national news and the controversy over the calculated grades. I know this only makes sense to the Irish students now. It won't make sense necessarily to the Nanjing students. While I haven't seen the details of whatever the coding problem was in the calculated grades, I can assure you that one of the reasons why there was a coding error is because the testing was not sufficient or good. It wasn't good testing. So anyway, that's by way of justification as to why we should talk about testing. So there's on Moodle, if you go into the automated testing section, you will find a set of slides. You don't have to have them in front of you. I'm going to step my way through them. This lecture now is going to be kind of unusual in the sense that it's a lot of talking and not demonstrating, which I don't like. As lecturing, it's nice to be able to demonstrate stuff, but we'll get to the demonstration for sure as we work our way through the other areas. But for this lecture, it's a bit talky, or a bit wordy, sorry. So automated testing, just want to give you some general points, and then we'll dig into unit testing in particular. All I'm saying here in terms of these kind of axioms or kind of mindsets is, as a developer, when you are in your kind of testing mode, you've got to be approaching it from the point of view that assume that there are bugs in your code and try to identify them. Don't test code just to prove to yourself that the code works properly. Try and check to see, are there actually bugs in there? Are your Maria trying to find the bugs that you know are in there? It's a mindset really more than anything, because it's quite easy to be lazy when it comes to testing, because certainly if you're testing your own code, you tend to assume, well, I've written the code, I know it works, I don't really need to do that much testing. And in fact, quite often what happens is you don't write automated tests for your own code, you do it for other people's code. But in general anyway, your mindset should be always, I'm trying to find the bugs that I know are there, rather than I'm just trying to prove to myself that the code actually works properly. It's kind of psychological, but anyway. Now, just in very general, and I think you've probably heard of these terms before, but there are three, this is kind of old terminology now, there are 3 levels of testing, and that kind of reinforces this idea that testing, a lot of it has to go on. But in terms of levels of testing, we have this idea of unit testing. That's where you're testing a particular unit of code within your application. Now, by unit, we typically mean a class. Although if it's JavaScript and you don't have classes and you're just using functions, then a unit would be a function. But in unit testing, your focus is just on testing that particular unit of code. Integration testing is where if the application that you're developing is interacting with some sort of external resource, be that a database or some sort of remote web service, then you want to test that that integration is working properly. That's what we call integration testing, which is very different from unit testing. And then system testing is where you're testing your entire application kind of from end to end. Now, when you're doing system testing, well, ideally, when you're doing system testing, you should no longer be finding bugs within particular units because if you've done your unit testing properly, you would have ironed out or removed all of the bugs within a particular unit. So when you come to system testing, you're really testing that the units kind of interact with each other kind of properly, i.e. when you've got methods of one class calling methods of another class, and all of that is actually working properly. So in system testing, you're testing the application as a single unit, if you like. And so you're testing the functionality of the system from a user's perspective. You're also testing the performance of your system, if performance will, it always is, if performance is an important issue. In other words, does your system respond quickly under heavy workloads? And that's very different from functional testing. So it's felt that you should do functional testing and performance testing. You keep those separate. Fourthly, in some cases, the clients, if you're developing an application for a client, the client may actually want to do their own testing, and we refer to that as acceptance testing. And that can be significant in some cases. Certainly if it's a large application that there's a lot of money being paid for the development, then your client may actually have their own requirements in terms of testing that the functionality and the performance is what they would have requested at the outset of the project. So 4 different levels of testing, but that's very much the kind of old terminology. Down at the bottom, I'm talking about the more modern kind of terms that we use, and particularly in relation to if you're developing a web application, and this is kind of linked now to the Web App Dev 2 module. But if you're developing a web application, then the notion of unit testing is still important. The second one there, API testing, is where you're testing in a web application. Typically what you have is you've got code running in the browser and you've got code running in a remote server. The remote server is often what we refer to as an API server, and the remote server, its only responsibility is to provide data to the browser after any kind of request from the browser. Now, providing that data may just mean retrieving it from a database and passing it on to the browser. It may also mean doing some sort of calculation or number crunching and returning the result of that calculation back to the browser. But essentially, the server is only responsible for returning data. It doesn't actually return web pages. So that type of server is called an API server or a web API. And obviously, we need to test that the API is behaving properly in terms of functionality and performance. And that's a separate level of testing. Thirdly, then I'm talking about end-to-end testing, which is really the kind of more modern name for system testing. And these are the terms that I will be using in this module. I'll talk about unit testing, API testing, and end-to-end testing. Now, when it comes to testing in an agile environment, as opposed to the kind of the waterfall model, then as I said at the outset, we really have to try and automate our testing. So, and this has become much easier in recent years. So there are lots of what are called testing frameworks available to us now that we can avail of. You see, essentially what's going to be happening is, as well as writing your application code, you're also going to be writing test code. So you've got 2 streams of code that you will be developing throughout a project's lifecycle. And that's a significant additional effort, admittedly, but the benefits are that having written your test code, you can actually run it multiple times, which is something that you would want to do as your application kind of expands, as you add new features to it. You want to make sure that existing features still work. How do you do that? Well, you simply rerun the tests that you wrote when you developed those existing features originally. So there is that benefit to be gained from actually writing all of this testing code. You can actually rerun it many times, something we call regression testing, which I think I mentioned on the next slide. But in terms of automated testing and testing kind of in the modern kind of agile world, we definitely need to use testing frameworks. For every piece of functionality in your application, let's say it's a method, for every method of every class in your application, you need to have a corresponding test for that method. Okay, so now you can see how your testing code can actually grow quite significantly. And in fact, sometimes there is more testing code than there is application code. Number 3 there, I'm saying when you do find a bug in your code, in your application during development, the first thing you should do is obviously fix the bug, but then, and the and is important here, you then also write an additional test to ensure that that bug isn't reintroduced back into the application by another developer making a change to the original code that you found the bug in. So you're constantly writing tests. Anytime you write some new application code, whether that new application code is in relation to developing a new feature or extending an existing feature or fixing a bug in an existing feature, every time you write new application code, you need to write associated test code to ensure that the new code that you've written still works or proves that the application code that you've written is actually doing what you expect it to do. Number 4 there, test-driven development. I'll talk about it at the end of this set of slides, but the idea is you would think that the normal course of action is you write your piece of application code, let's say a method of a class, and then you write your test code to prove that the method is working properly. With test-driven development, it's actually the other way around. You write your test first and then your application code. It's a very difficult skill to master and it requires a lot of practice. There is logic behind it though, and I'll explain the logic when we talk about it in more detail at the back end of this set of slides. So at the bottom then I'm saying, well, the consequence of all of this testing that we're doing and writing testing code, the consequences are hopefully there are fewer bugs in the code that you actually release out to the client. You identify bugs much earlier because you are testing almost immediately after you've written some new piece of application code. In the waterfall model, you only did your testing after all of your application code was written. And that tended to be at the very end of the development lifecycle. And usually at the very end of the development lifecycle, you're under pressure to release the application out to the client. And so you tend to take shortcuts in terms of doing your testing. And the obvious consequences then are you release code out to your customer or your client that hasn't been properly tested, and the bugs start appearing later on, and you have to do some maintenance on the application. Also, and that's really what I'm saying there about breaking the cycle of more pressure equals less testing there at the second last point. Also, it's argued that you're actually writing more maintainable code as a result of all of this testing that you're doing. Regression testing is something I mentioned there a while ago. And again, the idea is that when you add new functionality or extend existing functionality in your application, and of course, the existing functionality already has tests associated with it. But when you add new or extended functionality, you want to make sure that you haven't broken the existing functionality. And the way we do that is we rerun the tests that we wrote originally. So that's the value of all of this, writing this testing code, the fact that we can perform regression testing, and we're constantly kind of reassuring ourselves and proving to ourselves that we haven't broken any existing code when we start extending or adding new code to the code base. Does somebody have a question, I wonder? No, okay. So this is the kind of the value proposition. You know, if you think about it, if you are in a situation where you are developing an application and you know for certain, I will never have to add new functionality to this application, I will never have to extend it, then you could almost argue that all of this testing isn't beneficial because you never get to do regression testing. But of course, that scenario never arises. You're always extending an application's functionality after you've delivered it for the first time to your customer base. So regression testing is always a part of modern software development, and hence automated testing is really beneficial in the long run. Now, in order to write good tests, it's essential that you have a clear specification of the requirements of the application code that you're asked to develop. I mean, that's a statement of the obvious, I guess. You can't be expected, let's bring it down to writing a method for a class. You can't be expected to write a method for a class unless you have a clear specification for what that method is meant to do, what parameters it's meant to receive, and what it should return. That's your starting point. And without that, you can't write the method, and also without that, you can't do good testing. Because if you don't have a clear specification, how do you know how to prove whether the method that you have implemented is actually working or not? So that's your starting point. And I'm saying here that really, when you think about testing, really we're testing the specification against the specification rather than the implementation. Because the specification, if we assume that the specification is correct and it's a clear statement of what we've been asked to write in terms of our application code, then the test that you write should be written with the specification in mind rather than the code. You don't actually need to see the application code at all in order to write good tests, because you would use the specification as the basis for writing your good tests. That's where the truth is, if you like, in the specification, not in the actual application code. Down here, I'm saying that we write tests in terms of expectations of the target's behavior for a given circumstances and specific inputs. This is something that will become clear later on when we actually look at test code. But what I'm saying there is that when you're writing tests, what you've got to ask yourself is, well, if I invoke the method with these parameters, what do I expect the method to return back to me as a result? And I can be clear about that expectation, again, by going back to the specification. But in terms of how we write tests, this is what you'll find yourself coding in your tests. You'll be writing stating expectations in code, where the expectations are specifying what you expect the method to return as a result of invoking it with certain parameters. I'm using the term target there. The target of a test is, in this case, the method that you're invoking. That's what we just refer to it as the target. By circumstances, I mean, By circumstances, I mean, maybe you have to initialize a particular database with certain values in it, or there may be certain global variables that you have to give specific values to. These are all kind of the circumstances that exist before you actually invoke the application method or the target method that you're testing. So anyway, expectations is the term here that you just need to keep in mind. We write testing code in terms of stating expectations. And this is kind of an English example of what I'm trying to say here. I expect to get result X when I provide inputs Y and the database has data Z. Right, that's obviously English, but we can actually write something like this in the testing, using the testing frameworks that I've just mentioned there on the previous slide. The test target, as I said, is the thing that the piece of application that you are testing. The test target when you're doing unit testing is either a particular class or function, or a method of a class. The test target also is relevant when we're doing system or acceptance testing, the target being the entire application as a single entity. Likewise for end-to-end testing, the target is the entire application as an entity. So it's this terminology there is really what I'm getting across. Expectations, targets, these are terms that are related to automated testing. Also, in terms of writing good tests, I'm saying that you should think in terms of user stories. I don't know if you've come across this term user stories in relation to user requirements analysis. When you're doing user requirements analysis, it's suggested, this is kind of often a little bit of a tangent now, but when you're doing user requirements analysis, you have to write a set of user requirements as a kind of document in a document form. And it's felt that the way you should express these requirements is by following this given, when, then kind of style, which I'm mentioning here. We can actually express all of the, or most of the user requirements for a particular application. I'm thinking in terms of an entire application now, right? In terms of this given, when, then structure, right? And so if you maybe take the example here, right? So I'm writing some sort of application for a financial kind of environment. And maybe one of the requirements might be this, right? Given, and you can read it yourself, given my bank account, or a bank account, I suppose, is in credit. So that's the given part of my user story. The when part is when I do this. And the then part is, this is what the outcome should be. And that's a sensible user story, one user story. There would be many, many of them, but I'm following this given, when, then pattern for writing my user stories. Just some more examples, you know, the very simple ones really of this given, when, then user story pattern when you're trying to express user requirements. And again, you can read those yourselves. They're at the application level. I'm saying here that we can still use this given, when, then construct even when we're doing unit testing. And again, if you look at the example here, so the assumption now here is that I've got a specification. That's always my starting point. I've got a specification in English for a method of a class. And from that specification, it's possible to write these kind of user stories that I'm kind of illustrating in this slide here, even at the method level, down at the unit level, even though user stories tend to be related to the kind of bigger picture of applications and user requirements analysis. Now, I'm not saying that you necessarily need to, you could, but that you would write out these, you would write out these user stories for a particular method that you've been asked to write some tests for. But certainly it should be at the back of your mind. You should be forming them in your mind and then encoding them in whatever testing framework that you're using. So that's the idea of user stories and this given when then pattern. And the suggestion is when you're writing any type of tests, be it unit tests, integration tests, or system tests, then keep this pattern in your mind when you're actually designing your designing your test cases or your testing code. The very bottom there, I'm saying that, and you would have many of these user stories for, let's say, the method that you're testing. You could have many of them. And we refer to each story as a test case. So that term test case is what we use more often really when we're talking about automated testing rather than story, but they are related. So there are some high level just points and terminology: targets, expectations, user stories, test cases, unit testing, integration testing, system testing, end-to-end testing, API testing, regression testing. These are just terms that I've just tried to explain in the previous set of slides. We want to get down to more specifics though. So I'm going to talk in more detail now about unit testing in particular and about automated unit testing. And I'm going to be doing it in a JavaScript environment because that's what we are covering in web app development. And I said at the very outset last Monday that I'm trying to align this module with the web app development as much as possible. And here's one instance of it where we're actually going to use JavaScript as our programming environment. Now, I've just kind of lost track of time. Where are we in time? Okay, we're still okay. I've done a lot of talking though. I should just pause for a second just in case anybody has any questions. And again, I want to check people can hear me and can see the slides still, yeah?
Yep.
Good. Right. So automated unit testing. At last, we can see something tangible. So I'm going to talk about automated unit testing in the context of a particular little piece of application code. And I've taken the smallest unit possible, which is a class. So let's look at the case study. And this case study now is part of, in fact, if I go back to Moodle, if I go in, maybe I haven't revealed it yet to you. Oh, gosh. I haven't actually, you won't see this now actually, but once you have completed the JavaScript lab exercises in related to web app development 2, then the next lab after that, which would really be, I would say, maybe not even next week, but the week after, there will be a lab exercise on unit testing and using a framework called Mocha. And in that lab exercise, we are using this product catalog JavaScript class as our context. So anyway, let me show you some code. And Now, I did say in the earlier class this morning that we won't be using JavaScript classes at all. We are actually going to use it here, but I think this is probably the only time that you will see a JavaScript class, and it's pretty easy for you guys to understand this code, I think, because you've got a lot of Java in your background anyway. And so the syntax for classes in JavaScript is very, very similar to the syntax in Java. So I would expect you guys to have no difficulty interpreting this code. So here's my product catalog class constructor for it. And the important part of the constructor is I have an array of products in a catalog, which is empty initially. And I've got a method that, let's take this one here. I've got a method that allows me to add a product to the catalog, and I've got a method that allows me to find a product in the catalog based on it being passed in a product ID. And I've got some other methods as well that we don't need to worry about now. But in the lab, you will be adding on these other methods, and you will be well, I'll be giving you the testing code for them, and in other cases, you will write the test code yourselves. So that's the context, this catalog or product catalog class. It's common now that you would have all your tests kept separate. So obviously my tests are going to be in here. And we look at the detail of what's going on in here in a while. So that's my catalog, product catalog JavaScript class. And so, for example, as we saw, it has a method called find by ID. This is the specification for the method. It's a very trivial method, and so the specification is pretty straightforward. And I'm saying here, so in terms of testing, I would use the terminology that find product by ID might be the target of some tests that I write. The test cases, in terms of my given when then, there are obviously only two scenarios really, and I'm expressing the two scenarios here using my given when then kind of construct. They're all fairly simple now, I'll admit, but we need to start with simple examples before we can start dealing with more complicated ones. So those two given when then, you can read them yourselves, but they make sense in the context of the specification at the top of the at top of this slide. Now, in terms of testing my catalog class and the find product by ID, I mean, one approach I could take is I could just write a separate JavaScript script myself. I wouldn't have to use any testing framework. And that's really what I've done actually by way of illustration. So if I look at this here, this is just a simple piece of JavaScript script that I've written. Okay, so, you know, I'm just importing my catalog. I'm also importing the product. I didn't mention the product class, but it's fairly simple, really. It's another class, and it doesn't have any behavior, really. It really has a constructor. That's all that's important in it, with where a product has all of these attributes. But in terms of my kind of custom or my own testing code, I could do something like this, right? So I'm declaring an instance of my catalog. This is very Java-like, but this is how you create an instance of a catalog in JavaScript. I'm adding some products to the catalog. And then finally, here's where I'm doing my testing of my find product by ID method. And so I call the method with a particular ID, which I've initialized to here. And it looks like A123 is that one of my products? It is, yeah. So when I call find product by ID, then based on the specification, my specification said that that should return the product object matching the ID if it exists. Therefore, match should be a product object. And what am I doing here? I'm checking that the ID property of the product object, I'm checking if it's not equal to that, then that must mean that the method isn't working properly, because it should be equal to it. And I'm just doing a console.log saying that the test failed. Okay, so match here is going to be a product object, and as I said, here's my product class. So the product should have an ID property, but in particular, my test is just checking to see that it's what I expect it to be. Sorry, I didn't want to look at that. I want to look at this. And then I'm doing another test where I'm checking to see, does my method behave properly when I give it an invalid product ID? So it's all fairly trivial stuff. And I could continue on writing more tests down here when I start adding other methods to my product catalog class. So I'm writing all of my testing code just using pure JavaScript. That's fine for very small classes, but once your classes start to get any bit more complicated, and really our catalog class will, then this approach, this kind of custom approach, just doesn't scale properly. It doesn't scale well. And that's what I'm kind of saying here. And for that reason, and really that's what people would have been doing in the early days of automated testing when we didn't have testing frameworks available to us. But in modern days, automated testing, we do have testing frameworks. And so we should use a testing framework instead. And essentially what a testing framework will do for us is it will put a predefined structure on the code that we write, as we'll see in a few slides. So the problem with the custom approach is it just doesn't scale very well when your targets start to get a little bit more complicated. So there are unit testing frameworks for all programming languages, but all of these unit testing frameworks, they all kind of do the same thing, which is what I'm saying here. What they do is they force a particular structure on your testing code based on kind of best practice, really. And so you don't have to make any kind of decisions in terms of how you lay out your testing code. The framework imposes a structure on it. And it's true to say that it's much easier to maintain your testing code as a result of this enforced kind of structure, as you will see. In the middle there, I'm saying that really there are these unit testing frameworks for every language, and I'm mentioning some of them there, here. You may have come across some of them before. JUnit, for example, you may have touched on JUnit in some of your earlier module. In the case, sorry? No, in the case of JavaScript, there are a number of testing frameworks, but easily the most popular one is a framework called Mocha, and that's what we will be using. And I'm just making some general points at the bottom here that in the case of all of these frameworks, the features of them are, number one, they facilitate good structure of your testing code, as I've already mentioned. Number two there, I'm saying they provide a way of expressing test outcomes or expectations, that term I mentioned at the earlier on. So the framework provides syntax that allows to state expectations in an almost an English-like syntax. It's still JavaScript code, but it almost reads like English, or quite close to it anyway. And the third point, oh yeah, I mean, obviously you're going to have quite a lot of unit testing code it's going to build up quite a lot during the development of an application. And these testing frameworks provide ways of allowing you to run certain unit tests, all unit tests, a subset of them, as we'll see later on. So the Mocha framework, again, I need to check my time because I don't have a clock with me actually. Okay, maybe I'll just briefly touch on this slide. So in terms of the Mocha, pardon? No, okay. What the Mocha framework does, and it's really the same as all of the other unit testing frameworks in the other languages. So really what you'll find is if you start doing unit testing in another language, a lot of what you will learn here is transferable to those other frameworks in those other languages. So there's that kind of benefit, which is kind of nice. But I am saying there at the top that the Mocha framework provides an execution environment for your automated JavaScript tests. And there are essentially kind of three constructs that you use. So I said that the Mocha in this case, it enforces a structure on your unit testing code. So what you'll find yourself doing is you will be writing what are called describe blocks in your code. And your describe blocks can have other describe blocks nested within them. Also, a describe block can have what are called it blocks within them. So these are two constructs that are provided by the Mocha framework to facilitate the structuring of our code. And we also have this notion of before and after hooks. So these are the three constructs that you use. And I'm saying your testing code, then the structure is each test case. A test case, remember, is kind of linked to a given when then kind of scenario that you might have identified when you were designing your test cases. Each test case is wrapped in an it block. Your it blocks then will be nested inside a describe block, and your describe blocks could be nested inside other describe blocks. That's how you structure your code. You can also have these before and after hooks, and the idea is that the code inside a before hook would run before each it block nested within its associated describe block. It sounds a bit vague now, but maybe I should fast forward on to the next slide. This is what you will find yourself writing now. And it does look quite complicated, and in terms of the syntax, it looks very kind of noisy and intricate, but you just get used to it. So here's what I'm calling my outer describe block. And let's say this is a test for a particular class. So it's really just a JavaScript function, but maybe it's, well, yeah, it is. It's a JavaScript function that's provided by the Mocha framework. But it's also a unit of kind of composition in terms of testing code. And so my describe block here, I'm saying this is I would specify the class or unit that I'm testing, just in a string, really, the name of the class. The second argument of this describe function is an inner function, an anonymous function. I mentioned anonymous functions in web app development. And the more I think about it now, actually, because I haven't covered anonymous functions yet in web app development, I think I should actually just pause this lecture here, because otherwise this becomes very unwieldy and difficult to understand. So I think I'm actually going to stop here now, and I'm going to pick up the story really this time next week, which is when our next lecture is. And by then, I will have covered a lot more JavaScript in web app development, which is really the kind of sequencing that I want. So in terms of labs for this module, you should continue on with the JavaScript labs for next week. I will reveal the unit testing lab just in case people are interested in having a look at it, even though I wouldn't expect people to be able to complete the lab. So for now, I think I'm actually going to halt it there. Where's my camera? Right. That's it really. We have a minute or two if people have any questions. I'm not sure. It was a very, as I said at the very outset, it was a lot of talk really rather than demonstration, which is not easy to listen to. But from here in, really, I think lectures will become a bit more half and half in terms of explaining and demonstrating. Do you have any questions, I wonder? No. Okay, so we'll leave it at that, and I think I'll see you again on Monday in web app development. So bye for now.